Hello and good day everyone. I am Lihan and today I am going to present to you my bachelor project entitled Rainwater Treatment Using Rain Garden. So first of all, I'm going to introduce a bit about this project, and to do that, uh, I am going to introduce a bit about domestic rainwater, which is the greywater that's going to be used in this project. Domestic groundwater actually come from three main sources, which is from the kitchen, from the laundry, and from the bathroom. After being discharged, where does all this groundwater going to? So mainly nowadays, the kitchen groundwater is going to be treated directly to the treatment plant, which is actually quite costly due to the pollutant content in the groundwater. And another option is for reuse or recycle, but that is going to be impractical due to the high pollutant content. And the last option that can be used is using pre-treatment, which is to treat the water before releasing it into the drainage system, and this is going to reduce the cost for the treatment treatment plant due to the low pollutant content. And one of the pre-treatment for the greywater is actually by using rain garden system. Rain garden system is low cost and it uses biological means to treat greywater, which is through filtration of the pollutant and absorption of nutrient um, via the plant. And the objective of the studies is actually to design rain garden to treat kitchen groundwater. And the second one is to compare the pollutant removal efficiency of various filter media. And the last one is to investigate the best plant use for the rain garden system. In order to carry out this project, detailed methodology need to be designed, and I'm going to brief the methodology has been done in this project. And first of all, the filter media and plants that's going to be used is selected based on the literature review or the various studies done by previous researchers. And then the second one is to fabricate the rain garden and to arrange all the experimental setup. The fabrication is done after the sizing is done. The sizing is actually done by the calculation of the dimension of the rain garden from the discharge of the grey water from the housing. The third one is to sample the grey water, and this is done at the Taman Sri Sedang residential area, which is located near Masjid UPM. And the fourth one is to run the grey water through the rain garden. The fifth one is to test for the quality of the grey water before and after the before and after going through the rain garden. So after running through the experiment, it is found that the grey water from the Taman Sedang residential area is actually quite polluted, and it can be seen from the COD concentration, which is in the thousands. Because normally the COD in the grey water from the residential area is only up to the hundreds, but it can be seen here the COD in the side is up to 3000 plus milligram per liter. For this experiment, the quality parameters that's going to be tested is actually the pH, the suspended solid, nitrogen content, COD, and BOD. From this findings, it can be seen that the 250 mm filter media with lemongrass is actually have the highest pH improvement, which means that it can improve pH the best. As for the TSS, it can be seen that the 250 mm sand with lemongrass have the highest suspended solid removal, which is up to 96.1%. However, for the nitrogen removal, it can be seen that the 150 mm sand filter with lemongrass has the highest nitrogen removal, despite the filter media depth is actually lesser than the 250 mm sand filter. This can be explained by the pollutant load going into the rain garden, because in the 250 mm filter, during the test, the initial pollutant load, initial nitrogen load is actually higher than the one in the 150 mm filter. As for the COD removal, the 250 mm sand filter with lemongrass has the highest COD removal, which is up to 80%. And the BOD removal is estimated through the BOD and COD ratio, which means that the BOD removal is estimated through the value of the COD removal. So it can be seen that despite not using any chemical, the pollutant removal is quite high. So from this, we can conclude that the treated groundwater does not meet the standard value due to limitation of design passive since passive system is used. Because this project, this rain garden is designed with the assumption that no water pump is used. So the filter depth is quite limited. And then, despite having high pollutant removal capability, the system can further improve through addition of pump. This is like I said just now, the use of pump can remove the limitation in the depth of filter media that's going to be used. So high pollutant removal and high pollutant load can go into the filter media. So that's all from me. Thank you.